In today's lesson, we are going to look at more complicated examples of how to solve trig equations. In this first problem, we have the trig functions of cosine and secant, and we want to be able to get these to be the same type of function. So what we'll do is we will go ahead and we will rewrite the secant as a 1 over cosine. Now we talked about how you are not allowed to divide both sides by a cosine theta. However, you are allowed to multiply everything by a cosine of theta. After doing this, we get the equation 2 cosine squared theta plus cosine theta equals 1. And we can subtract the 1 to the other side, giving us 2 cosine squared theta plus cosine theta minus 1 equals 0. This here is a quadratic. Like we talked about the other day, when we see these quadratics, just think about them as if the trig function was a different variable, such as a. And in this case, if I wanted to factor this would factor into 2a minus 1, a plus 1. So we're going to factor our quadratic with cosine in the same way. We will have 2 cosine theta minus 1 times cosine theta plus 1 equaling 0. Now what we want to do is set each of these factors equal to 0. So the first factor would give us that 2 cosine theta, if we add the 1 to the other side, equals 1. Therefore, cosine theta equals 1/2. And for our second factor, we get that cosine theta equals negative 1. Now from here, we want to think about all angles in the full circle. We look at our restrictions. Our restrictions tell us that we want our answer to be in radians. So I want to think of all radian measures that have a cosine ratio of 1/2. And this happens twice, at pi thirds and 5 pi thirds. And the cosine equaling negative 1 only happens one time, and this happens at pi. Now, we want to make sure that we are checking these solutions. The only function that is allowed to be undefined here is secant. So you want to ask yourself, is secant going to be undefined at pi? And the answer is no, because at pi, the ratio would be 1 over negative 1, which is a possible value. So this problem has 3 answers, and all 3 of those answers still work. Now if we look at our next problem, we have sine squared theta divided by secant squared theta. If we think about what we know about rational functions, we know that the denominator is not allowed to equal 0. The only way that a fraction can equal 0 is if the numerator equals 0. So this is all that I need to focus on. I say sine squared theta equals 0. We square root both sides and get that sine theta still equals 0. Now there are 2 answers where sine equals 0, and that happens at 0 and pi radians. Now again, I want to make sure we understand secant squared theta equaling 0 is not used because the denominator of a fraction can never equal 0. So all we need to do is focus on the numerator. All right, now in example 3, we want to go ahead and use the same idea that we did in example 1. We are going to rewrite cosecant as 1 over sine, and then to go ahead and get ourselves a quadratic, we are going to multiply everything by sine. So I multiply the left by sine theta and the right by sine theta, and that leaves me with the problem sine squared theta minus 1 equals 0. All right, pause the video, factor, and solve on your own, recognizing that our answers need to be in 0 to 360. After we factor, we get sine theta plus 1, sine theta minus 1 equaling 0. We set each of those parentheses equal to 0, and then we can go ahead and solve, giving us the answers of 270 and 90 degrees. Another way that we could solve this problem is set the, if we move the cosecant over to the right, we now have sine of theta equaling cosecant theta, and we just want to find all angles where the sine and cosecant functions have the same values. In example 3, we're going to go ahead and approach factoring. And if we look at this, there are no numbers that multiply to equal negative 1 and add to equal 3. So this problem is not factorable. And because of that, we are going to need to use quadratic formula. And as mentioned yesterday, you are allowed to use poly or solver in your graphing calculators if you have that. So we can say that secant theta equals, we do opposite of b, so negative 3 plus or minus b squared. So 9 minus 4 times a times c, all divided by 2a. And if we go ahead and solve this, this is going to give us two different decimals. And those decimals are that the secant of theta equals 0.303 and the secant of theta equals negative 3.303. All right, so from here we need to enter these in the calculator. Now, when we recall how to enter a secant inverse, to do a secant inverse, if you don't have an 89, you need to do cosine inverse of 1 divided by whatever ratio you are trying to solve for. Now, if we try plugging in the first one, we are going to get undefined. And the reason why this is undefined is because 0.303 is not a valid ratio for a secant function. Recall that secant has to be greater than 1 and less than negative 1, and 0.3 is clearly neither of those. So in this case, we cannot take the inverse of it, and there is no angle associated with that ratio. The next one is, on the other hand, possible because secant can equal negative 3.303. So just like the previous one, we are going to do cosine inverse of the reciprocal. And this will give me, and let's check our mode, we want to be in degrees. So if I type this in degrees mode, I will get 107.623 degrees. Now, I'm trying to find the whole circle, and I know that there are 2 times this angle happens. Once in quadrant 2, and the other time is in quadrant 3. So if we visualize this, the first angle, the 107 angle, is around here. And we need to get the other angle, which is down here in quadrant 3. So to get this angle, think of it like this. From start to the angle is 107.623 in the positive direction. From start back to the third quadrant angle is also 107.623 degrees, but in the negative direction. So if we take negative 107.623 degrees and add 360 to it, that'll give us our angle in quadrant 3. You can also think of it like 360 minus that angle. And this gives me the answer of 252.377 degrees. All right, last problem. In this problem here, we can't really use any of the methods that we have done so far. First of all, tangent and secant don't have anything in common. It's not like they're reciprocals. And let's say we were to multiply both sides by a cosine. All that's going to do is give us a problem that has 2 different functions that we can't factor. It's not going to help us. However, we should recall from this problem here that tangent and secant, they are connected with a Pythagorean identity. So whenever we see that we have 2 terms in our problem that are connected with a Pythagorean identity, what we want to do is we want to square both sides. We want to do a substitution with that Pythagorean identity. We want to finish the problem, and then this is crucial. After we finish the problem, we must check answers. And you won't need to check your answers in the original problem. This is mandatory for any problems where you square both sides. You have to do this because you almost always have one of your solutions not work. All right, so if we square both sides, remember we need to FOIL on the left because that is a binomial that we're squaring. So we get tangent squared x plus 2 root 3 tan x plus 3 equals secant squared x. And at this point, we can replace secant squared x with tangent squared x plus 1. So the left side of the problem remains the same, no changes there. Except now this is equal to the tangent squared x plus 1. And that is very helpful because we can subtract a tangent squared x from both sides. This is allowed. This is not the same thing as dividing both sides by a function. Okay, I just want to make sure that is clear. We are allowed to subtract the same thing from both sides. So now at this point, we want to isolate this tangent of x function. So we're going to minus 3 divide both sides by the 2 root 3x, or sorry, just 2 root 3, and that'll give me that tangent of x equals, and then after we rationalize, negative root 3 over 3. All right, so when does that happen? Well, tangent is equal to negative root 3 over 3 at 5 pi 6 and 11 pi 6. Okay, so now we need to go ahead and check these answers. All right, so we want to plug them into the original problem. So we are going to say tangent of 5 pi 6 plus root 3 equals secant of 5 pi 6. And tangent of 5 pi 6 is equal to negative root 3 over 3 plus root 3. And then secant at 5 pi 6 is equal to negative 2 root 3 over 3. All right, now to combine like terms, we are going to turn that guy into 3 root 3 over 3. And when I add on the left, I get positive 2 root 3 over 3 equaling negative 2 root 3 over 3. And we should know that those are not equal. So since those are not equal, we have to cross off 5 pi thirds as a possible answer solution. If we do the same thing to check 11 pi 6, we will get the tangent of 11 pi 6 plus root 3 equaling the secant of 11 pi 6. And this will give me the tangent of 11 pi 6 is negative root 3 over 3 plus root 3 equals the secant 11 pi over 6 is positive 2 root 3 over 3. And we will find out that 2 root 3 over 3 also equals 2 root 3 over 3. Therefore, 11 pi 6 is our answer. All right, so the big question of the day, when do we check answers? There are 2 crucial times that we need to do this. The first time is when we square both sides of an equation to solve. And this was like what we saw in example, in the last example, example 5. We introduce extraneous solutions when we square both sides, therefore we have to check them in the original equation. The second time when we have to square both sides is when we have functions that could be undefined, so functions that can be undefined, and that would be your secant, cosecant, tangent, or cotangent, and quadrantal angles are part of your solution set. And just to refresh quadrantal angles, that's 0, pi halves, pi, 3 pi halves, etc. All right, that's it. Thank you and have a nice day.